Yo, AP Stats. This is going to be a chapter by chapter review. I got asked about this week, so hopefully you find this to be valuable. So, chapter one is just exploring data. Main things telling if a variable is quantitative or categorical. Quantitative, it's going to have units. Being able to display categorical variables. That would be a bar graph, a side by side bar graph, a segmented bar graph, a mosaic plot. Pie graph's not part of the AP, so not really worried about that. Two-way tables and probability questions involving like marginal conditional distributions. Marginal involves the totals. Conditional distributions are just conditional probabilities, probability of A given B. You might be asked to describe the association with a segmented bar graph or a side-by-side bar graph. Are these two categorical variables like eye color and gender, are they related? They could ask you to make a box plot, stem plot, dot plot, time plot, histogram for a quantitative variable and then describe that. That's VSCO. The variability is range, IQR, standard deviation, outliers and gaps, center. Are you using mean or median? The shape, is it roughly symmetric? Is it uniform? Like all roughly equal, skewed to the left, skewed to the right. I don't know why I have variability on here twice. Okay. It's standard deviation. What does that mean in context? It's the average distance from the mean. Don't forget context. I should put this on here. It's VSCO plus context. Always answer in context. If a distribution's skewed and you're talking about the center and the variability, you want to use median and IQR because they're resistant. If a distribution's roughly symmetric, you want to use the mean and the standard deviation because they're resistant to skewness. Okay. If you have a symmetric distribution, the mean and median are about the same. If the distribution is skewed left, the mean is pulled down, so the mean's less. Skewed to the right, the mean is pulled up, so it's greater than the median. If you're asked to compare distributions, you have to have comparative words. Greater than, less than, similar, different, higher, lower. The median is greater than this median. There's more variability in this distribution than this one. Not having those words will cause you to lose credit on your AP rubric. So that's quick chapter one. Chapter two, this was dealing with the normal model and cumulative relative frequency histograms. It's a fancy way to just see, say, percentile graph, where it just kind of keeps going up until it hits 100%. That was part of chapter two. We learned about the normal distribution, the 68, 95, 99.7 rule, and we formalized that to get a z-score. To get a z-score, you take your value minus your mean divided by your standard deviation. That gives you a z-score. That measures the number of standard deviations above or below the mean you are. We said anything 2 or 3 standard deviations or more away from the mean is considered unusual. Oh, going back up here, speaking of unusual, outliers. You need to know the formulas for outliers, and I'll talk about that at the end. So calculate and interpret a z-score. Knowing how addition and subtraction affects measures of center, spread, and just measures of location. So if you add and subtract, if I add 50 to everyone's test score, measures of center are going to change, mean and median. Measures of location like min, max, quartiles, they're going to change. But the measures of variability are not changing. So range, IQR, standard deviation do not change because I'm just shifting the data. I'm not changing the distance between the data points. Multiplying and dividing we called rescales. Those affect everything: measures of center, measures of variability, and measures of location. Every normal model has two parameters, the mean and standard deviation, mu and sigma. We use the calculator features quite a bit, inverse norm and normal CDF. If you're asked to find a percentage, probability, area under the curve, you're going to use normal CDF. If you're given a percentage or a percentile, you're going to use inverse norm. You're always going to put, unless you have a fancier calculator, you're going to put the percentage that falls below that value. Calculate and interpret percentiles. Percentile is some value that there's, if you're in the 80th percentile for height, 80% of the data is less than or equal to your height. Determining if a distribution is approximately normal, you can look at the shape and see if it's bell-shaped. You can check, does 68% of the data fall within one standard deviation, 95% within two, to get a sense. So that's really the first unit of the AP. That's exploring data with one variable. Then unit 2 is exploring data with two variables. And this is where we talked about in chapter 3, regression. So being able to describe a scatter plot with direction, outliers, form, strength. Understanding the word correlation, that does not prove causation. We'll come back to that in chapter 4, I think. Linear regression, how to calculate a least squares regression line, either on your calculator, from a regression output, how to write the equation, or using the formulas on your green sheet. Calculating and interpreting residuals, that's one of the formulas not given to you that you want to know. Residual equals actual minus predicted. Determining if a linear model is appropriate. Few things you want to check. Do you have two quantitative variables? And then is the scatter plot straight in form? And does the residual plot have no pattern? And is it consistently spread? Like, you don't want any kind of fan or cone or Christmas tree type shape. Regression towards the mean, that's not a concept that we really talked about. I wouldn't worry about that. Interpretations, interpret the slope, the y-intercept, r squared. So remember, slope and y-intercept, you should be saying like predicted. As somebody's height increases by 1 inch, we predict their arm span will increase by 2 inches. Y-intercept, somebody who's 0 inches tall, we predict will have an arm span of 5 inches. We don't typically see the y-intercept being asked for an interpretation because it typically doesn't make sense. R squared in context, that's literally your correlation squared. So if the correlation is 0.9, R squared is 0.81, which we changed to a percentage, 81%. So that's the percent of the variability in the Y variable that's explained. So if we go height is explanatory, arm span is response, it would be 81% of the variability in arm span is accounted for by height. That means there's another 19% that's accounted by something else. Extrapolation, that is the concept of, if I have, say, people's ages from 20 to 50, and there's some kind of positive trend between age and net worth, how much money you have, that I don't want to use values less than 20 or over 50 to make predictions. Even though I have a regression model that I can plug a number into, I don't want to do that because I don't know if these trends are going to continue. That concept is extrapolation. High leverage points, outliers, influential points. If we're looking at a scatter plot, high leverage means a point that's really going to pull the line towards it. It's typically an outlier in the horizontal direction. Outliers could be in the vertical direction. They have large residuals, or the horizontal direction. So those high leverage points are typically influential because they typically pull the line towards it, and they're outliers in the horizontal direction. Interpret the values of S. S is the standard deviation of the residuals. So that's your typical distance between the actual values and the predicted values. R squared. So you want a small S value, small standard deviation of the residuals, and you want a large R squared value. That means you have a really strong, well-fitting model. Okay, chapter 4 is getting into collecting data, they call it. And this is all about sampling and experiments and observational studies. So good samples and bad samples. Good samples come from random samples. We talked about 4 different types. Stratified, which is you break the population into similar strata, grade level, 10, 11, 12. And then you do a simple random sample of each grade level. I randomly select some 10th graders, some 11th, some 12th. That's stratified. Simple random sample is each person in each group has an equal chance of selection. So if you're sitting in a class of 20 people and I say I'm going to randomly pick 5 people, just names in a hat, I could pick out any 5 people. That's a simple random sample. Systematic, that's where you have a random starting point, and then you go like every kth person after that. So if we have 20 people in the class, I generate a random number 6. I start at the 6th student, and then I go every, say, 5th person after that. depending on how big I want my sample size. Cluster. Cluster is, think of lunches. Lunches have 10th, 11th, and 12th graders in them. Clusters are like mini populations. And then I'm going to randomly select some of my clusters using a simple random sample. So I put lunch 1, 2, and 3 in a hat. I pick out a number. Say I pick 3. Then I sample everybody in that lunch. So once you randomly select your clusters, you sample everyone in those clusters. Bad samples, convenience. Hey, I'm just sampling the people who are in front of me because it's convenient. They're typically not going to be representative of the population. Voluntary response sample, that's bad. People are choosing to be a part of it. This is any kind of online, click here, call in, you're at a store, how did we do today? Those are all voluntary response samples. People with strong opinions one way or the other are typically the ones answering. Types of bias, non-response. This is similar to voluntary, but do not confuse the two. Voluntary, you choose to be in the sample. Non-response, you're chosen as part of the sample. So you didn't have a choice to be part of it. You were chosen to be part of the sample, and then you either A, did not respond, or B, they could not get a hold of you. That's non-response. Response bias is anything that is done that influences the results. So this year we talked about, I think his name was Peter. He was a Boy Scout. He was going around his neighborhood wearing his uniform saying, will you support the Boy Scouts or do you? So there's response bias for 2 reasons. 1, he's going to his neighbors, people that know him. And 2, he's wearing his Boy Scout uniform and asking about Boy Scouts. Response bias could be wording. The question is worded in such a way that it influences your response. Under coverage. Under coverage is if your sample is not representative of your population. You're undercovering the group you're trying to analyze. You have to be able to recognize the difference between a population, the large group, and a sample. Remember, if you sample the entire population, that is called a census. And that's okay. It's just very hard to do. If they ask you anything about bias, you have to include the direction. So if I'm standing outside the library and just doing a convenience sample, asking people how many books they read a year, I need to say something like, 1, that's a convenience sample, and the people that are going into the library are probably not representative of all students and how much they read. And then I need to go further and say, that's probably going to create an overestimate for the number of books read because the people going into the library are more likely to read books. The question will not tell you to include the direction. You need to know that. All right, the second part here is like talking about the difference between an experiment and an observational study. Observational studies do not control any variables. They're not forcing any treatments. They just are watching what happens. We talked about 2 different types. We talked about retrospective, going in the past using existing data or past data, versus a prospective observational study. Prospective observational study is going into the future or tracking people into the future. Neither one of those can ever conclude causation. The best thing you can conclude from an observational study is there's an association between playing an instrument and having a high GPA. Why can't you conclude causation? Because there's other potential confounding variables that could affect somebody's GPA besides do they play an instrument or not. For an experiment, we have treatments are being imposed onto subjects or experimental units. You can conclude cause and effect as long as you have a well-designed experiment with control, randomization, replication, comparison. If you have those, then you can conclude cause and effect. But remember, for an observational study, association does not prove causation. Huge concept there. So there's 3 different types of experimental designs. Completely randomized. I have 100 subjects, 2 treatment groups, randomly assigned half to treatment 1, half to treatment 2, using a random number generator or the hat method. Randomized block. If I think 10th, 11th, and 12th graders are going to respond differently to treatments, block by grade level, and then within each block randomly assign some sophomores to treatment 1 and 2, some juniors to 1 and 2, some seniors to 1 and 2, and then compare within the blocks. What is that doing? That's controlling, that's a measure of control, because I think grade level might confound my experiment. So that's going to decrease the variability. Matched pairs is a specialized block design. It's a block of size 2. Typically, it's the same person receiving both treatments. In class, we did the standing and sitting pulse rate, and then we compare you to yourself. Or it could be two very similar subjects. Same age, same height, same weight, same gender, same health levels. And we do the one person stands, take their pulse rate. One person sits, we take their pulse rate. There's all sorts of vocabulary in this. Blind. Single blind is typically the subjects are the ones who don't know which treatment they're receiving. It could also be the people measuring the response variable. Double blind is both of those parties. Neither the subjects nor the people measuring the response variable know which treatment the subjects received. Having a placebo goes a long way. If you're taking a pill, you don't know if you're getting the real pill or the placebo. Blocking. Statistically significant means your results are significant, so you can conclude that A caused B. Taking this pill caused a decrease in blood pressure. Scope of inference. Two main things here. If you've done a random sample, you can generalize those results to a larger population. If you've done a random sample of, say, high school seniors, then I could generalize to all high school seniors. If I've done a random assignment, then I can conclude cause and effect. Okay? If there was no random sample, you can only generalize to people of your study, very similar to those people. That's it. Okay? And if there was no random assignment, you're not concluding cause and effect. So I'm going to stop here. That's the first 4 chapters. In the next video, we'll cover chapters 5, 6, 7, and 8.